Hello, in today's vocoder update video, I thought I'd lay out all the filter boards here on my desk. So I've got 4 of these dual filter boards and 8 plug-in filters. So there are 8 filter channels in total. Now, in the last video, I showed you that I was having a problem with filter board number 12. I have since fixed it, but I think I'll go through the problems I had and what the solution was, because, well, I think it's quite interesting. But I'm going to take these filter boards out now, and you might hear something in the background. So this filter board provides a DC level, and that controls the VCA. Now, if you take the board out, it seems to lift that voltage slightly up, or allow it to float up. And you can hear sound coming through the filter. And if I take these out in turn, you'll hear all of the different buzzing. You'll hear all of the different filter frequencies going down in frequency as I take these all out. Mustn't touch the audio input. And now you're getting broadband noise because it's coming through, to a limited extent, all of these filters. So I'm going to lower the volume of the vocoder right down low so you can barely hear it. Now if I put one of this board in, which has a fault on it, and this was in the last video, it opens up the filter completely to allow all that noise through. And again, I can move it between the various filter channels on these boards, and you can hear their frequencies. So I needed to find what was wrong. Now I did point out in the last video that this chip had gunk from the roof of my shed drop down onto it, and it's a bitumen impregnated roof panel, and when it got wet, I think some bitumen came down and it kind of coats the board in this incredibly hard substance, almost like varnish. It's very difficult to get off, even with a knife. It's very hard to scrape it off. So I thought, okay, maybe that chip's not making a very good contact. So in fact, one of the first things I did was lift this chip out. So that's a dual op amp. I think that one's a TL082. And then think, okay, has that fixed it? No, that hasn't fixed it. So is the problem with these 2 chips? Okay, let's take out the next chip. This is another dual op amp. This is a 1458. Let's have that one out. Got to try and remember which chip's which now. Okay, so let's plug that in, see if that fixes it. No, that's still not fixed it. So is it the 741? That's a single op amp, 741. Let's take the 741 out, which kind of leaves the board with no active circuitry on it at all. So it's not going to be able to make that noise, surely. And indeed, no, it doesn't. So then I thought, okay, I'll swap the 741 with another 741 from another board. So that's what I did. So let me just put the 741 back in if I can. I can't see which chip's which. One moment. So as I say, I swapped the 741 with one from another board. Let's try that. That's still got the problem. But if I'd waited, the problem goes away. It fades out. Now let me take these links out actually, because they're providing feed through from all the other filters, and I want a clean background so that we're not hearing any noise from the other circuitry. So that's disappeared. Now, when I was trying to fix this, it took me several hours yesterday, and I hadn't realised that if I'd just left some time, that 741, it's got capacitors around it, and obviously when the charge dissipates from those, it quietens down. So it's not actually the 741 that's the problem. And in fact, let's put it in a filter channel over here. That means I'll have to put a link on this filter channel. So it's that one now. But again, hear how that faded out. Now I can, if I put my fingers on this, charge that capacitor back up, and then it allows noise through this channel. But again, if you leave it, it fades out. So that 741 is absolutely fine. I think now we need to take a look at the schematic. So this filter board, which looks like that, is this circuitry up to this point here. So I'll put a dashed line there. And so it's a dual op amp here with the filter components around it. Now this is a bandpass filter with a very narrow band of frequencies that's allowed through it, and speech from the microphone goes into this filter, so a narrow band comes out. This is a precision rectifier which turns the AC of the audio coming through that filter into DC. It's a positive, I think it's all above the 0 volt line. And then this is a filter, a low pass filter. And you can think of this, if you think this is AC, this is the rectification and this is the smoothing. So here you get a DC level. So the speech goes into this filter and then it's not really used. It's rectified and smoothed and becomes a DC level representing the amount of sound in this filter. So at the back end of this board, it's just a DC level. And the fault on the board is that there's obviously a high DC level, which is getting through to the rest of the circuitry on the baseboard, turning on this VCA and allowing sound from the excitation, which is just wideband noise, through a corresponding filter of the same frequency and to go to the final output. So obviously what's happening with this fault is that there is a high DC level on the output of this board when there shouldn't be. It should decay away to no DC level. So putting back in the dual op amp, which is the precision rectifier. So this is the filter, this is the rectifier, and that's the smoothing, the low pass filter. Put the 1458 chip back in, and we've got that high DC level which is opening up that filter channel, which is allowing a particular band of noise through, and it doesn't decay away. So something is holding that DC level high, which is holding open the voltage controlled amplifier, which is that chip there, and allowing that signal through. And that doesn't decay away, but if you take the 1458 out, the 741 does decay away. Just go back to the schematic a minute. So this low pass filter is just a unity gain op amp, that's a 741. And I think the reason it stays open and then gradually fades down is because there's a 47N capacitor there on the POS input, non-inverting input I should say. And if there's some voltage on there, of course it'll be the same voltage on the output. Now as that voltage fades away, this is high impedance input of course, so it takes quite a while, then the output DC level will also fall in unison. And so it's these capacitors that are holding that open. But as I say, the 741 is fine, but there appears to be a problem with this 1458. So, I don't know whether you can see this, there is actually a Sharpie X on that 1458, because that I identified as the problem. So let's take out that 1458 and get a replacement. So in goes the replacement 1458. And let's try that. Absolute silence. So yeah, this 1458, which I've drawn the little X on, there's something wrong with it. Its output goes high and stays high, regardless of what its input is. So yeah, that's faulty. And that's from new, because this filter board had never been used prior to me making this board fitting these two sockets, which is all this board was waiting for. I just didn't have these sockets. So I ordered them recently and they came in, and I've soldered a couple in there. So yeah, that was a dud chip. But that's fixed the problem with this filter board. And now when you put it in, it's completely silent. When you take it out, there's a couple of resistors. I'll show you them actually, because I think that's why the filter channel is opening ever so slightly. There's this thing called bias, So I would imagine that 0 volts DC here goes through all this lot and then doesn't open this VCA, this voltage controlled amplifier. But there's this bias circuit here which is mostly pulled down to ground, 100 ohms, but has 10k to 12 volts, so it's slightly lifted up, and that connects across to here. It's shown separate because it actually goes to all 14 channels. Single resistor network here is connected to the 10k resistor, or was that? No, that's 15k. But I think that's lifting this point up sufficiently that it's just slightly opening this VCA. It closes off completely when you put the board in and all the chips are working. But I think that's why there's a bit of breakthrough now. So now that, let's just move the camera a bit. Now that filter 12 board is okay, actually, where is filter 12 board? Oh, it's over here. I didn't put back the TL082, did I, in this position? And I got a funny feeling that's actually working, but we'll try it. I'll put the TL082 back in there. But you can see that this is looking really manky. Let's see if I can get that focused. There's all that detritus all over the socket. And I think it's partly bitumen that came off the roof of the shed. Lost my TL082 now. That's, yep, that one. So that goes in there. Now I can fit all 12 filter boards. Sorry, not 12, 8 in this instance. They go up to number 12. I think the lowest one is number 5, that's right. But just before I do that, I'm going to fit these links. I'll turn the volume up slightly. Oh, I'll turn it all the way up. So you can hear the sound coming through channel 8. You can also hear mains hum if I put my finger on it. Okay, so number 7. Now the links alternate. So on the odd numbers they're forward and on the even numbers they're back. And that's something to do with this adjacent channels need to be they need to be inverted with respect to each other. I did cover this in a video called Deep Holes some years ago, but you can watch that if you want to know what that's all about. But let's put these on. So that's number 7, number 6, number 5. Let's go up now, number 9, number 10, number 11, and channel 12. So they're all now slightly bleeding through, but now I'm going to fit the filters, and because they work now you shouldn't get that horrible squealing. That's number 12. There's number 11. 10. So this once again shuts up all these channels. That's number 7. Let's put that in there. When I touch these pots, mains hum gets in there. I don't quite know why. Number 8. Number 5. Number 9. And so just number 6 left, which is this one. I think it's not written on the front. Yeah, it's written on the back, number 6. Ooh, and that goes now completely quiet. So now what I'll do is I'll get the voice coming in to the voice comes in on the ribbon cable, goes onto the bottom board but doesn't stay there for long, and then comes up onto the speech filter, which you just saw the schematic for. And so voice goes up to all these speech filters. That's why I use ribbon cable, because it's kind of a bus, because it's supplying that same voice signal, microphone signal, to all of these speech filters. And then of course they each go through a different bandpass filter with a different frequency, and they're turned into DC by the rectification and smoothing, the low pass filter, and then they lift up the VCA, depending on how much sound level is in that particular filter frequency. Right, let's get the microphone set up. Right, okay, I've got the microphone connected, so if I bring that up to my mouth, I can talk through these 8 vocoder channels. I'm now going to dip my microphone, which is it? Is that one? No, that's reverb. Let's dip that and now only talk through the vocoder microphone. I'll try to speak as clearly as I can, but it still might be difficult to understand what I'm saying because there isn't much high frequency content. Okay, that could be quite difficult to understand what I'm saying because, as I say, there's not a huge amount of high frequency content in here. What's the frequency of channel 12? I think I've got a diagram of that somewhere. Yeah, so here's the frequency diagram, and channel 12 is there. It's right between 3 and 4 kilohertz, so let's call it 3.5, even though this is a log scale. Now, some of you were saying in the comments on the last video that you can't hear beyond 3 kilohertz, which I think was a bit of an over-exaggeration, but certainly my hearing's probably topped off at about 10 or 12 kilohertz now. And of course, if the highest frequency of the vocoder is 3.5 kilohertz, then you're not going to hear the S's and T's and all the other sibilant sounds. But let's just go back to the vocoder itself for a moment. Now, of course, I'm only vocoding the, let's bring my microphone up so you can hear me. I'm only vocoding the tone generator at the moment. Maybe it'd be a bit better if I do the noise generator. So let's take the tone down, bring up the noise generator. Okay, I'll turn my headset mic down. So now I'm speaking through the vocoder with a maximum frequency. Yeah, the sibilants are coming through there, even though the maximum frequency is only about 3.5 kilohertz. Yeah, I mean, when I do S sounds, they do come through. They're a bit muted. Now there is additional circuitry in the vocoder so that ultimately speech is made more intelligible, I think is the word, isn't it? But anyway, that's it for this video. I just wanted to talk. Oh, one thing I didn't mention actually. I'll just take out filter 12. I did think at one point it might be decoupling because there's very little decoupling on all of this. There are 2 tantalum capacitors right up at where the power goes in, but there's no other decoupling in the whole of this circuit, and there's nothing at all on the speech analysis boards, the speech filter boards. But that didn't make any difference, so it seems that decoupling isn't actually necessary. The thing's not noisy. And it doesn't go unstable without the decoupling. I mean, I might as well leave it on there, but I did just try that. But yeah, it didn't make any difference. Let's put filter 12 back in. And the vocoder. Now, I assume we're hearing sound through this filter 12. I assume all the filters are working. I mean, I could test them in turn. Oh, should we make this a long video? Shall I test them in turn? By just taking all the links out. So let's take the links out. So that's filter 11, that's filter 10, but can you still hear the, let me just get around my microphone, can you still hear the high frequency of filter 12? I suppose only one way to find out, and that's to take link 12 off. Has that made any difference? If I put link 12 back on, then I can't hear any different. Let's keep taking these off. Link 9, link 8. You should be able to hear me in the background because I've still got my microphone there. Link 7, link 6, link 5. So is anything coming through on channel 12? Doesn't sound like it is actually. No, it seems that channel 12 is not working. And of course that could still be that this chip here is not actually making contact with its socket, and therefore, although I've got rid of that DC level thing that was high, whoops, it's still not actually working on this filter board, possibly because I need to replace the socket for that chip. But no, that's not making any sound. If I plug that in, there's nothing coming through the vocoder at all. Okay, so we still have a fault. So actually, if I get that filter board working, then there will be even more high frequency content. So yeah, it looks like we're only listening to the bottom 7 filter frequencies. I need to get that fixed. But anyway, that's enough for this video, so cheerio. Actually, what the heck, let's make this a longer video. I'll turn my microphone down now on my headset and I'll just talk through the vocoder microphone. So let's turn that. I'm going to be able to hear anything. So let's have a little bit of my standard microphone just so you can hear. But anyway, that's what's coming through on channel 11. Now I'll add channel 10 into the mix. Actually, let's only listen to channel 10. These links are quite difficult to get off. So that's channel 10. Gosh, it's not very loud, is it? Okay, let's try. I really need to find a link. Oh, that's quite loose, actually. That's channel 9 coming through there. That's channel 8 coming through there. Channel 7 sounds like that. Channel 6 sounds like that. That's very resonant. Channel 6 is a bit weird. And finally, channel 5 sounds like that. Okay, let's start adding all the channels. Channel 6 added to the mix. Channel 7, filter bank 8, filter number 9, filter number 10, and finally filter number 11. And yes, I think you can see that filter number 11 is doing all the high frequency work. So the addition of filter number 12 would be extremely handy. So I do need to get that IC socket